Hello. So we are going to continue talking about the volume of a solid of revolution. So what we did in section 7.2, we discussed the case that we can find the volume of a solid that's going to be generated by rotating a region along the x-axis. That method was called the disk method because the result was a circular disk. So we are going to consider another method. The method is the case that you are going to change the axis of revolution. So it's going to be the same region, but this time you are going to rotate it along the y-axis. The name of this method is going to be the shell method. So I'm going to describe it, and I'm going to tell you how we're going to find out when a function would be given to you or when the region is given to you, how we're going to pick the correct method to do the job, okay? So I go to my lecture notes, notebook, and then I'm going to continue. Okay, so this is going to be 7.3. This is a kind of last section that you cover before your quiz one. Okay, so this is going to be 7.3, and this is going to be volumes. How we're going to find the volumes of the solid of revolution by using the cylindrical shell. Okay, by cylindrical. Okay, that's it. Cylindrical shells. Okay, and in short, this is going to be what is the shell method. So what is the shell method? Shell method. It's very easy to identify when are you going to use this method. Okay, so we recall that so far what we did. Okay, recall that. By the disk method, the one that we did so far, the volume, okay, the volume of the solid that is produced or that's generated, okay, the volume of the solid, and that is going to be generated by rotating the region enclosed by this graph, y equal to the f of x from x equal to the a to x equal to the b, but you see about the x-axis. X-axis is given by that is going to be your formula. The formula is the volume is going to be equal to, okay, it was integral from a to b, just pi, and that's it, f of x squared times tx. Because the cross section was a circle, okay, a circular disc, and we find the area of that circle, which was pi r squared, and we multiply by the thickness, that gives us the volume. So this is going to be the disk method. Okay, so in this case, this is what we have. Okay, in this case, this is going to be the graph of the function. Okay, the graph of the function, and this is from a to B. Okay, that's the region in question. And what we did, we are going to rotate it along the x-axis. You know that we partitioned it and we rotated along the x-axis. So the result was a disk. Okay, that was a kind of a disk that we're going to have, a circular disk, and for this circular disk, we just find we find the volume of one portion, which was f of x squared, pi r squared, pi of r squared times the thickness over here. So the radius of that cross section r was f of x, and the thickness was delta x, and we find it. Now the reason that we can do this one with the disk method is that look at the axis of revolution. You see axis of revolution is going to be x-axis. So the axis of, that's it. Axis of revolution is the x-axis. And look at your function. Your function is y equal to the f of x. So anytime the function is a function of x and the axis of a revolution is x, you're going to apply the disk method. Okay, so x disk method. Or if it's going to be y. So the axis of revolution, the variable of the axis of revolution, and the function is going to be the same thing, then use the disk method. If they are going to be different, so if this is a function of x and you want to rotate this one along the y-axis, then you are not going to use the disk method. So that's a disk method. Okay, disk method. But if you switch it, you see, what is going to be the shell method? So the shell method. The shell method, your function, for example, your function, your axis of revolution, for example, if your axis of revolution is going to be y-axis, okay, but your function, so this is going to be the function. Okay, your function is y equal to the f of x. You see the variable in the function is x, but the axis of revolution is y. If this is going to be the case, you cannot use the disk method. You have to use the shell method. So what would happen in this case? You see, this is going to be the case. So when you partition the region that you are going to have, okay, so if this is going to be the curve, and this is going to be the region that you're going to create it, okay, so that's going to be your region. Now this time you want to rotate it along the, rotating along the y-axis, So the situation is going to be anytime you partition it, you know that we partition it different parts, and then we are going to create it. See, this is the way we did it. If you partition it now, if you want to rotate it, each of these rectangle, you see the rotation in this case is going to be, you are going to get one cylinder when you go with this part. You see that's going to be one. Then we're going to get a bigger one if you get that part, okay? This is going to be the case. So it's going to be the same thing on the top. You get one inner circle, if you like, and you get one outer one. So you see, each portion of the region would create a double cylinder, if you like. And these are going to be, you get two circles, the inner and outer one. The center are going to be the same. The center of a circle will be the same, but they are going to have two different radius. Okay, so when you put them all up together, you get a collection of these cylinders, if you like. So that's why the method is going to be called cylindrical shell. So what you have to do is exactly what you did over here. You see, for this part, we find the volume of one of these discs, circular discs, then we add them together. So we have to do the same thing here. You have to find the volume of this cylindrical shell first. So we are going to explain this one first, okay? Cylindrical shell. and we find the formula for the volume of one cylindrical shell, and then we add them together to get the answer. Okay, so it's nice to know it. Otherwise, we can write the formula. Okay, so the big thing is you just look at if the axis of revolution and the variable in the function are different, shell method. If they are the same, x, y, y, disk method. Okay, if they are different, shell. If they are the same, disk. Most of the time they give you the method, but on the test, we give you one, and we want you to identify the method yourself. Okay, so what I'm going to do, I'm going to explain one of these because this is a kind of unusual one, and the way we're going to use it. So first, we introduce the so-called cylindrical shell. We find the volume of one of these, and then we come back and we add them together. That would give us the shell method. Okay, so let's introduce this one. So this is going to be a kind of cylindrical shell. So what is a cylindrical shell? So in the case of the cylindrical shell, let me just go to the next page because I need more space. Okay, so the question is going to be, what is cylindrical? So you must know this. What is a cylindrical shell? So we're going to talk about this first, then we come back. The formula is much easier than the other one, but I would like you to see it because when you are in calculus 3, you're going to do this type of things to create a new formula. So that's why let me just be patient a little bit, then you get it. So what is going to be a cylindrical shell? It's going to be a double cylinder. Okay, so the definition of a cylindrical shell. So what is a cylindrical shell? A cylindrical shell, just using different color. Okay, a cylindrical shell is going to be is going to be a solid, a three-dimensional solid. It's going to be a solid enclosed by two circles with the same center. We call them two concentric. Okay, concentric with the same centers. Right. Okay, right circular cylinders. That's it. So this is what we refer to it as a cylindrical shell. So this is a situation that we have. You want to graph it. You get one circle inside. Okay, this is the smaller one. Then you are going to have a bigger one outside. So this is going to be a bigger one. Okay, so there's going to be an inside one. Okay. So this is going to be the inside cylinder. Then you're going to have an outside one here. Okay, so this is going to be the outside one almost here. This is it. So the center are going to be the same, but two different radius. So the radius of the inside one, let's call this one, okay, let's call this one R1. Then the bigger one, call this one R2. Okay, so it's a kind of a double cylinder I'm going to consider. So we would like to know what's going to be the volume. So the volume of a three-dimensional solid is going to be, that's it. So note that. A little bit of algebra before getting to the calculus part. So the volume. Okay, so the volume of this solid is going to be, as usual, area. Okay, area of the cross section. That's section, cross section, and then times it by height. Okay, so this is going to be height. So the area of a cross section times height. So in symbolic form, this is going to be the volume, and this is going to be the area of a cross section times the height. Now let's find out. So the cross section is going to be this double cylinder, okay, double circle that we have. So we have to find the area of this. Okay, so it's going to be the area of the bigger one of the circle, pi r. Pi r squared would be the area of a circle. So it's going to be the area of the bigger one, pi r 2 square minus the smaller one. Okay, so this would end up with what? So this is it. So the volume would be equal to the area of the bigger one is going to be pi r 2 squared minus the area of the smaller one is going to be pi r 1 squared. Okay, times that by height. So we can call the height to be equal to the h. Okay, so this is going to be the height. We call it h. And so this is going to be times h, which is height. Now, a little bit of algebra. So we're going to factor out the pi. So that gives pi r2 minus r2 squared minus r1 squared times the height. Factor this one. So the volume would be equal to the pi times r2 minus, okay, r2 plus r1 times r2 minus r1 times h. Okay, that's going to be the one. Now, what we are going to do, you see, when we partition it, then we would like to change this one into the Riemann sum and change it to the integrals. Remember this R2 and R1 as we did it before. This is going to be a difference when you do the partitioning one. In fact, these are going to be something like xi, okay, the partitioning of the x-axis. So that gives difference between like xi minus 1 and xi. So we can call this one delta x for our purposes of integration. So the difficulty is this one. Okay, if this is going to be something like 2x values, the difference between 2x values is going to be called delta x. But the sum of 2x values, you don't have anything for this one. And besides, this would be outside of the interval and you won't be able to do anything about it. So what we are going to do is we would like to get a number between R2 and R1. So what we would like to do, we change this one to the half. If we divide it by 2, we see find the average. So a trick is this one. This is going to be equal to the, so what I'm going to do, I'm going to multiply this one by 2. See, I multiply this one by 2 to make it 2 pi. Then I have R2 minus plus R1. Now I'll divide this one by 2. That's a trick. So this 2 would cancel out, so I haven't done anything wrong. But that would give me R2 minus R1 times H. You see, that would be no easier formula to apply because this is going to be difference between two X values, and this is going to be the average, and the average is going to be inside. So we have a formula to be able to apply. So the volume is going to be what? So the volume of the cylindrical shell, the format that we would like to use it is going to be, this is it. So the volume is going to be 2 pi times 2 pi. This is going to be the average. Okay, average. Okay, average of those two. Okay, average of the radius that you're going to have. Okay, average of that two. Okay, this is it. Two radius that you have, or radii. Okay, this is going to be the average. Then the rest is R2 minus R1 is the one that we can call it a thickness, because this is going to be a difference between these two circuits that we have. So just for a while, you can call this one thickness and times the height. Okay, we don't need it. We operate it right away. Okay, so so sorry, this is the format that we can handle it in order to find the volume of that. Okay, the volume of the region in question. If you go back to see how we're going to use it, remember, if you want to use the cylindrical shell method, this is a situation that we are going to have. You should look at this one. So that's the region in question. That's the region in question. Then remember, we partition it. If you partition it, we divide it into different parts. Okay, that's going to be different parts that we're going to have. So partition that we use, remember, A is something like x0, then we get a x1, x2, x3, up to the B, which is going to be your xn. That's a partitioning one. And then what we do is we just make some rectangles here. Now we are going to rotate it along the, okay, rotate it along the y-axis. So what I'm going to do, I'm going to pick only one of these to explain it, okay, because that volume would be the sum of these. So what I'm going to do is just pick one of these, just to explain it for you. It's the way we do the Riemann sum in this course and in calculus 3. So consider only one of these. So suppose this is one of those rectangles, because each one of them would give you a cylindrical shell. And this point is going to be, suppose this point is going to be called xi minus 1, and this point is going to be xi. It doesn't matter, it's going to be just 2 points. Now, when you rotate it, you see when you rotate this one, you're going to get a cylinder here, a circle. Okay, so it's going to be the smaller one. And you're going to get one here, equal distance. Okay, that's going to be the one. And the same thing on the top. That's going to be the same thing on the top, okay? So that gives you a cylindrical shell. So we're going to get one cylindrical shell for each of these rectangles. Now, what we would like to do is, now we would like to find the volume of this, the one that we created. So what's going to be the volume? Just using this formula. So the volume would be what? I write it down here. I'm going to call it VI. Okay. So the volume is going to be 2 pi. The average of the radiuses. Okay, the radius or radio. Okay. So the radius is going to be, you see, a distance of xi minus 1 to the origin is the smaller radius, and the xi, the distance from the xi to the origin, is going to be the bigger one. So this would be, in fact, what? It's going to be xi minus 1 plus xi divided by 2. That's the average. Then the difference. And the difference between these, okay, the difference would be the difference between these two is going to be xi minus 1. That's the difference times the height, which is going to be h. Okay, now you know that this is the one that we usually call it delta x. Okay, it's going to be a delta x. So the VI is going to be equal to the 2 pi times this average. Okay, so it's going to be times this average that we have. So the average is this average. We are going to call it a point like a CI. So it's going to be a point. We call it CI times H. H is the thickness. The thickness is going to be just the y coordinate of the point. Okay. So this is going to be delta x. It's going to be delta xi, and the h would be something like f of the ci. Okay, so we find the average, and we just We multiply them together. So there is going to be a CI, a number, any number, a number. You can pick any number you like when you use the okay, the Riemann sum for the integration. So the number that I pick are going to be just the average one. So I pick this one to be CI, and f of CI, I pick it to be equal to the, okay, to the height. So this is going to be true for I equal to the 1, 2, 3, up to the n. Okay, so this is going to be the volume of one of these portions. So you're going to have, okay, for each of these rectangle, you're going to have lots of these cylindrical shells all together. So if you add all these together, the result is going to be the volume that we're going to be interested in. Okay, so it's interesting to see how we constructed. The result is going to be very easy. So the volume in question is going to be approximately the sum of these volumes, the sigma of VI, I from 1 to n. Okay, so this is going to be, in fact, V equal to almost equal to the sigma of the volume. The volume that we create is going to be 2 pi. Okay, that's going to be 2 pi. And then we get the CI, we get the delta XI, and we get the F of CI. Okay, I equal to the 1 to the n. Okay, so this is the volume of one of them. You know that you can do the finer and finer partitions if you increase the number of the partitions. So the V is going to be, in the language of calculus, is the limit of the sigma of. So this is going to be 2 pi CI F of CI times delta X. I from 1 to n goes to infinity. This is going to be the volume in question. And you know that this is a Riemann sum. We can change it to a, okay, to the integrations. The way you're going to change it, these CIs would be changed to the X, and this delta X would be changed to the DX. So you arrive at this formula. The volume is going to be integral of from A to B. A to B, this would be 2 pi, and this would be X, this would be F of X, and that would be D of X. Nice. This is going to be the volume of the solid of the revolution if using the shell method. Okay, you can pull out the pi, 2 pi if you like. Some people they write the 2 pi outside. So it's going to be 2 pi integral from A to B x f of x dx. Okay, so this is going to be, you must be careful. This is the volume. Okay, the volume of the solid of the revolution, solid of revolution that's generated or produced, that is generated by rotating, okay, rotating the region under the curve, the region y equal to the f of x from x equal to the a to x equal to the b. Okay, rotating this one about the y-axis. Y-axis. You see, this is y and this is x. When the variables are different, you are going to use the shell method. Okay, so this is going to be the shell method. So you must be careful to use the correct formula. It's very easy to identify. Excess of revolution, the variable different using you're using the shell method. If both of them are the same, x, y, y, you're just using the disk method. So that's going to be the formula for the shell method. It can be done always also with the area between two curves. If it's going to be two curves, instead of f of x, you are going to have only a difference. So I'm going to give a couple of examples, okay? So we are going to be interested in one that you directly find it for us for next quiz. And we give you one and would like you to test it using two different methods, the this method and the shell method. And you must show that both methods would arrive at the same answer. Okay, so this integral is much easier to evaluate. This integral must be easy all the time unless you miss this x. Okay, you got to be careful. You cannot. This is x times f of x dx. Okay, x times f of x dx to get this number stuff. Okay, so let me just show you how we're going to use it. So this is going to be the case. It's very easy, easier than the other one, and it's quite quite interesting. And the problems in your book are, of course, they are very easy, but we have some on that practice quiz that we have to check. Okay, so this is one of them. Number one, two different problems. Okay, or three if you like. This is the first one. The first one is would like you to find the volume. You're not going to give it the name of the method in your book. Sometimes they give you the name, but would like you to recognize it yourself. Okay, find the volume. Find the volume, okay, of the solid, volume of the solid generated or produced, generated when the region, when the region, okay, enclosed by, region enclosed by this function, y equal to the radical x from x equal to 1 to x equal to 4, okay, x equal to 4 is going to be is rotated, or when the region enclosed by this is going to be is rotated about, okay, about the y-axis. You can use your calculator if you like to graph it. You can do it right away, really. It's not going to be a big deal. Okay, you check to see which method they are going to use. You see solution, your function, you see the function is y equal to the radical x, which is a function of x. Axis of revolution, okay, axis of revolution is what? Y-axis. So this is y, this is x. They are different. Shell method can be used or should be used. Okay, if they are the same. This is f of x and this is x-axis, then you are going to, okay, so in that case, you are going to use the this method. But in this case, the shell method, okay, the shell method should be applied or can be applied, okay, okay, can be applied, or should be applied. Okay, so there are the formula for the shell method. V is equal to integral of from 1 to 4. The function is f of x. We're going to be x f of x d of x. That's it. Okay, you don't have to graph it if you want even to graph it. Y equal to radical x is easy to graph. Okay, you get x equal to 1. You see, don't need it, or you can use it, check it with your calculator. So if x is, you see, if x is equal to 1, that would be 1. X equal to 4, that give you 2. So if you locate these points on the xy coordinates, so you're going to get a 1, 1. This is going to be 1, 1. and you get a 4. So this is, suppose this is 4, and you get 4 and 2. This is going to be 4 and 2. So this is going to be the part of your graph. So the region in question is this one. And as you can see, you rotated along the opposite axis. So your region is perpendicular to the x-axis, but you rotated about the y-axis. So that's why the shell method can be applied or should be applied. If you rotated along the x-axis, you get a circular disc. But since you rotated about the y-axis, you get a cylindrical shell. Okay, so it will be very easy to identify. Substitute integrate. So v is equal to 1 to 4 x times radical x dx. You know that to integrate it, you have to change the radical x to the x to the half. So that give you integral of 1 to 4 x to the 3 half dx. I add the power. Okay, 1 plus 1 half, 1.5. Now you integrate it. So that give you x to the 5 half. Because you add 1 to the top, divided by the 5 half. No constancy, going from 1 to 4. You take care of this one, reciprocal, so that give it 2/5. Okay, 2/5 x to the 5 half, going from 1 to 4. Now you substitute, it's going to be 2/5. You can use your calculator to get these numbers. 4 to the 5 half minus 2/5 times 1. So this is going to be equal to, you see, 4 to the 5 half, 4 to the 1 half would be radical 4, which is 2. Then 2 to the 5th would be 32. This is the way you are going to find it, or calculator. Okay, we go 4 to the 1 half first, which is 2. Then 2 raised to the 5th, which is 32. So that gives it 2/5 times 32 minus 2/5. So that gives you 64/5 minus 2/5. So the final answer is going to be, okay. Oh, I missed something, sorry. I missed the 2 pi. In the formula, there is a 2 pi here. Okay, you can put it outside or inside. It's a 2 pi times. So I usually put it outside. So this is going to be 2 pi. Okay, 2 pi. And at the end, I multiply 2 pi. Okay, you can multiply it outside or inside. So this is going to be times 2 pi. Okay, the formula would have 2 pi, sorry about it. So that gives 62, okay, 62/5 times the 2 pi. So 2 times 60 would be 128, 124, 124 pi/5. That would be the volume. There is no unit, so we write it down as is. If there was a unit, we apply the unit for that. Okay, so don't miss the 2 pi. I missed the 2 pi here for the formula. So it's very easy to identify the method. Make sure to recognize the method yourself. Okay, so function, you see, you cannot change the axis of revolution. This is fixed. Sometimes you may be able to change the function, but you cannot change this one. So focus on this. Yx, Yx. They are different shell. If they are the same disk. Okay, that's it. That's a case one. I give you another one. Okay, so you get to know these. So the next one is a kind of like a washer method that we have. We can rotate a region between two curves and get this one. Okay, so this is going to be the same thing, but your formula, your function they're going to use is going to be a difference of those functions. So this is a type 2. Type 2, kind of the volume type, a region between two regions, a region between two curves. So what we'd like to do is we'd like to find the volume. Okay, find, that's type 2. Find the volume of the solid, generated by, okay, by, or generated, let's see, generated when, we have to write this expression all the time. Generated when the region, the region, okay, the region in the first quadrant, the region in the first quadrant, okay, first quadrant, okay, enclosed by, that's it, enclosed by two curves, okay, enclosed by these curves, y equal to the x, and the y equal to the x squared. But, okay, that's it. Find the volume of a solid generated when the region in the first quadrant enclosed by the y equal to the x and y equal to the x squared is revolved or rotated. That's it. About, okay, about the y-axis. Y-axis. That's it. Let's see. So you have two functions, not big deal. You just the difference between these two to get your formula. But you have to check to see which method are going to use. See, focus on the functions solution. You see the situation that we have is the functions are two functions, no big deal. We find their difference and you work on it. Okay, but the excess of revolution, you see, excess of revolution is y-axis. See, the functions are functions of x, but your excess of revolution is y. They are different. So this means the shell method. The shell method must be applied. Must be applied. You have two functions. So this is your formula. Say v equal to 2 pi integral from a to b. X would be as is, but use the difference of these two functions. Okay, the function on the top, if you like. So this is going to be the function on the top minus the function down the bottom and the dx. This is because, you want to get a positive. It doesn't matter. The difference, the volume must be a positive number. If you miss it, your result would be a negative number. Then you change it to the positive. Okay, so not a big deal. But before getting in, as we did it for the disk method, you need to find the A and the B. Since two curves are given to, you have to intersect it to see what is going to be the, okay, A and the B, okay? So you need algebra. Okay, so be careful. When two functions given to you, you can use something similar to the disk method. In fact, we find the volume of the first one, we subtract it from the second one, as you did it with the case of the disk method. So x would stay the same because x times f of x would be the volume of one of them, and x times g of x would be the volume of the second one. Okay, so find the point of the intersection first. So you have the functions y equal to the x and y equal to the x squared. That's it. Use substitution method to get the x. So that gives x squared equal to the x. Move it to one side, x squared minus x equal to the 0. So factor out the x. So that gives x minus 1 equal to the 0. You're going to have two solutions, x equal to the 0 and x equal to 1. So x is a positive number, so x is going to be between 0 and 1. So you are going to be in the first quadrant, nothing to worry about. You don't have to graph it, but if you want to graph it, you can use your calculator graph or just doing it as is. It's easy to graph. You see, you have a straight line, y equal to the x and y equal to the x squared. So your straight line is it's going to be 0, 0, and this is going to be 1, 1. Sorry. So this is going to be the line. Okay, this is going to be the line, and this is going to be 0 and 1. And your curve is going to be the same thing, but the curve is going to be below the line because x is between 0 and 1. So it's going to be a parabola type, you see. So this is the one. Again, you don't have to graph it, but that give you better understanding. And then you rotate it opposite axis, you see. If you rotate it along the x-axis, you create a circular disk. But if you rotate it about the y-axis, you're not going to creating a circular disk. You are going to creating a bunch of cylinders. So that's why you have to use the cylindrical method, okay? So you are in the first quadrant, that's fine. Sometimes if you get more numbers, okay, over here 0 and 1 are here. So you don't have to worry about it. Okay, there you are. And now, as you can see, the line is on the top. So this is going to be y of the top is x, y of the bottom is x squared. Even if you miss it, it's not a big number. It's not a big deal. Or if you want to show, you pick a number between 0 and 1, you substitute if you don't graph it. For example, if you pick the 1/2, so if you take x equal to the 1/2, y would be 1/2. If you put the 1/2 here, 1/2 square would be a quarter. So 1/2 is bigger than a quarter. So the line is on the top, okay? Because this difference must be positive. But anyway, if you miss it, no problem. The volume must be a positive number. You change it to positive. Okay, now we are ready to give you the formula. So v equal to the 2 pi integral from 0 to 1. This is going to be x times x minus x squared dx. That's it. Okay, carefully multiply the x inside, and then you integrate 0 to 1. So that gives x squared minus x cubed dx. Okay, continue integrate it. 2 pi, and that gives you x cubed over 3, and that gives x to the 4th over 4. I'm going from 0 to 1. If you put the 0, you get nothing. If you put the 1, so that gives you 2 pi times, okay, 1/3 minus a quarter, minus 0. So that gives you 2 pi. Common denominator would be 12. That gives you 4 minus 3. So that gives you 2 pi. Okay, so that gives you, that's it. So that gives you 1/12. Now we can simplify 2 and 12, so that gives us a pi 6. Sorry, it's a pi 6. So the volume would be pi 6, and then with that. Okay, so it's going to be interesting and easier than the disk method, but make sure you are not going to miss it, the method. Okay, so that was the second case. We're going to have a third case. The third case is you don't have this type of problems in your book, but it's going to be lots of fun to have it because we give you two methods, okay, the disk method and the cylindrical one. So what we are going to do is we are going to give you one question, and we would like you to do that question using both methods. Okay, one of them is natural. You see, the natural method for this one is shell method. But if you don't like the shell method, and if you want to switch it, sometimes you can switch it. Okay, you should be able to switch it all the time, but sometimes it's not going to be possible. So this is going to be your the last question that we have, and we give you one of them on the quiz. So it would be lots of fun to see it. And the book that you use is for this your college Larson, but the one that we use at the university is the Stuart. In the book Stuart, we have this type of problems quite a lot, or in any other calculus book. Okay, so why not? Let's check one of them. So this is there's going to be just one group of problems, not a big deal. It takes a little bit time, but it would be interesting to know it. Okay, so this is the last possibility that we may, the last possibility that we may see. Why not? We're going to get all of them. There you are. We give it a function. It's going to be mostly the kind of a washer types, the region between two curves, and would like you to use two methods and show us that you arrive at the same answer. Okay, there you are. I think you have one example in your book. Find the volume. Okay, find the volume of the solid. Volume of the solid obtained. Okay, obtained by rotating. Obtained by rotating the region. Rotating the region. Bounded. The region bounded by the curves or the graph curves. What is the curves? The curves are following x equal to the y squared, and the other one is x equal to the 5. Okay, so the region is going to be bounded by these two about the y-axis. About, okay, that's important. About the y-axis. Y-axis, okay. Now what we'd like to do is by, that's the fun part, by both methods, both the shell method, okay, the shell method, okay, and the disk method, and the disk method. So that would be fun, okay, to do it using two different methods. Of course, we should arrive at the same answer. Okay, there you are. So we want to test this one. What we are going to do is, you just, as I talk about it, one method is the natural one that we have to use. Check to see which method is possible as is. You see, look at the axis of revolution. Axis of revolution is y-axis, and the functions are the functions of y. See, y. Everything is the same. Since everything is the same, okay, so the natural method that you can use for this one is the disk method, because all of them are the same. So first thing to do, you use the disk method, you find the volume. But they ask you to do it also by the shell method. For the shell method, they must be different. See, for the shell method, you cannot change this one. This must be as is. So this is y. So if you want to do it by the shell method, they must be a function of x. So you have an extra job to do. You have to change this one as a function of x. So what you can do, you can solve this one for y. Y would be a fifth of x. And then you can solve for y, that give y equal to the radical x. So in this type of problems, in one of them is straightforward, it's as is given to you. But for the other one, you have to do the algebra. You have to switch yourself. Okay, so this is how we're going to recognize this. But before that, you have to find the intersection points in both cases. So first thing to do, you have to intersect these two together to find the intersection points for the integration, and then go for this. Okay, so it's very a straight problem, but it would be interesting. That's why we want to know all the possibilities. So solution, first thing to do is find the intersection points. It doesn't matter, for both methods you need it. Find the range of the x and the y. Find the intersection, okay, intersection points of the curves. That's the important part. Easy to do, just this x equal to the y squared. Okay, and the x equal to the 5y. Substitution method, let them two equal to each other. Okay, so this is going to be y squared equal to the 5y. Move everything to one side of the equation, use factoring. Okay, you factor out the y out, so that give y minus 5 equal to the 0. So you have two solutions, y equal to the 0, okay, and what? And y equal to 5. So y is between 0 and 5. Okay, that's it. Since you want to use two different methods, this is the range of the y. You better find the range of the x as well to be ready for it, okay? So you can substitute these numbers in one of these two equations to get the x. So y equal to the 0, I just use the first one. So x would be 0, 2. Y equal to the 5, I use the second one. X would be 5 times 5, which is 25. So at the same time, x would be between 0 and 25. So if you integrate with respect to the y, you have the range of the y between 0 and 5. If you integrate with respect to the x, that gives you 0 and 25. One of the mistakes of the people who do this type of problem is the one that they use the same number in both cases, which is not true. Okay, so shell and the disk in this problem would have two different variables. If the variable is x, you integrate respect to the x. If the variable is y, you integrate respect to the y. So you got to be careful. Okay, now that was the step one. Now we are going to do it. As I talk about it, you pick to see what's going to be the natural method. As we talk about it, the natural method is y, y, y. Everything the same. So the disk method is the natural one. So we're going to use the disk method first. Okay, that's it. Disk method. We apply the disk method because our functions are x equal to the y squared. Okay, x equal to the 5y. And we have a y axis of revolution is just y. So y, y, y. So the disk method is what? The volume is equal to, in the disk method is going to be pi integral from, okay, now you have to find that a and the b. I write down for you a and the b. Okay, the function is going to be function of the y, so you have to put the, remember, this is it, the function to the right minus the function to the left squared. Okay, that's a f of x squared if you like, times it by, since the variable is y, dy. Okay, so this is going to be, if you don't like this type of method, it's the same as saying that the pi a to b, okay, let's say f of y squared minus g of y squared d of y. So since the variable is y, you integrate respect to the y. Now you already got the y. Y is between 0 and 5. So your integral is going to be integral of pi 0 to, okay, that's it, 0 to 5. Now, which function goes first? If you can do it if it's going to be a positive answer, so you're done. Very good. If you miss the function that you put up in front, you may have, sorry, this is x to the right, this is x to the left. The function. Okay, it's very easy to identify which one goes first. Just pick a number between 0 and 5, and you put it in this function to find which one is bigger. If you pick 1, that give you x equal to 1, that give you x equal to 5. So this is the function, the bigger one, or the one to the right, okay? So I go with the y squared first. Y squared squared okay, minus 5y squared dy. Okay, it's not a big deal. So suppose you missed it. If you miss it, if you put the 5y squared, you get a negative answer. So you change it to the positive. Or you can play it safe. At the beginning, you say, oh, I'm going to use the absolute value. If you put the absolute value, that's for safety. If you get a positive number, you're done. If you get a negative number, you say, oh, I did use the absolute value, so this must be positive. Okay, so it's not a big deal, but it's easy to check. 0 to 5, pick a number like 1, x equal to 1, x equal to 5. So 5 is bigger than 1, so 1 there. Okay, that is going to be, in fact, I missed it. Sorry about it. This is 0 to 5. I go with the 1, so that give you 1 and okay, 5y. I stay with this one so that you can see it's not going to be a big deal. Okay, so what I do is I do it when I get the negative number, I change it to positive. Okay, we can switch it. So not a big deal. So this is going to be equal to the pi 0 to 5. So I don't want to rewrite it. So that give me y to the fourth. Okay, minus 25y squared and dy. Okay, carefully square this. Okay, now integrate and then substitute to get the result. Okay, I'm going to go to the next page. So this is not a big deal. The bigger function here, it's going to be this one. But, since I wrote it, I just continue. Just put the absolute value around this one to know that the volume is positive. So if this is going to be positive number, I got it. Otherwise, I change it to the positive number. Okay, I'm going to integrate respect to the y. This would be y to the fifth over 5 and 25y cubed over 3. So continue. This is it. V equal to, we got the pi integral from 0 to 5. Okay, so I'm checking again. First one was y to the fourth, so that's going to be y to the fifth. Okay, minus 5, and the other one's going to be 5y. That's the second one, 5y, 25y squared, so that's going to be y cubed over 3. Okay, I just missed this one. I don't need this. Sorry about that. Okay, that's going to be 0 to 5. First, I want to rewrite it, but I integrate it. Okay. Now, carefully substitute to get the number. Okay, let's see. If you put the 0, we get nothing, but we have to put the pi and simplify it. So v is equal to the pi. Okay, pi times, this would be 5 to the fifth. Okay, over 5, and this is going to be minus 5, and that gives me 5 cubed over 3, and minus 0. Then you can use your calculator to simplify these numbers. Okay, so if you don't want to use calculator, you can do algebra. Okay, you can use calculator if you like, but this is the way I am going to do it. Okay, I simplified a little bit first. I pull out the 5. That gives me 5 to the fourth. It's going to be 5 to the fifth. Okay, over 5 minus 5 to the fourth over 3. Okay, that's the one. So this is the way I simplify it. I pull out the 5 to the fourth as a factor. Then the rest would be easy to operate. Okay, so that gives me 5 over 5. And that gives me 1/3. Okay. So it's going to be kind of pi. I stay with my method because that gives me 5 squared, 25 times 25, 625. 625, and inside you use your own calculator. I don't have it now. So that gives me 625 times pi, common denominator 3, 3 minus 1, which is going to be 2. So 625 pi times 2/3. Okay, 2/3. So the volume is going to be equal to, what's that? 3 times 5 would be 10, 5, and 12 pi third. So this is the volume. Okay. So this is going to be the the volume for the first part. So we did it using what? So we did it using the natural method. The natural method is this method. Okay, now what you've been asked to is just do it using the shell method. So what's going to be the shell method? In the shell method, you have to change it. Shell method. Let's see what you have. See what we have? We have two functions. We have x equal to the y squared. Okay, and we have x equal to the 5y. And we have what? We have the y-axis. Y-axis. So you cannot change this. You have to keep it. So the axis of revolution is y. In order to get the shell, your function must be a function of x. They must be different if they are the same disk. You cannot change this because this is fixed. So what we're going to do, we change this one. See, look at this. You solve for y, just y equal to the radical x. You don't have to write positive, negative x because x is a positive number. You already got the x between, okay, between 0 and 25. So you don't need it. And over here, you're going to find the y. Y is a fifth of x. You see, this is your job. And now this is y-axis. Look at this now. Y, x, x. So the axis of revolution and your variables are different. So this means you are going to use the shell method. That's it. Okay, so what's going to be the shell method? The formula, v equal to 2 pi integral from a to b, x times the difference of two functions, like f of x minus g of x and d of x. You see that's going to be your shell method. Now your x, we already checked this one. Remember, you use 0.5 for the y. But when y0 was 0.5, remember, your x is between 0 and 25. Must make sure you use two different numbers. This is x, the other one was y. So you remember that your x is between 0 and 25. Again, you must make sure that this difference is going to be positive number, okay? X is between 0 and 25. Okay, if you put x equal to 1, that give you 1, that's 1/5. So this is the bigger one. So stay with the radical x pairs. Again, if you miss it, you get a, you get a negative number, then you switch it. Okay, so you can graph it to see it, or just pick a number between 0 and 25 and substitute. I pick x equal to 1, so that give me y equal to 1, but that would be 1/5. So this is bigger. I put this one first so that I get a positive answer. So it's going to be 2 pi from 0 to 25 x times the difference. Radical x minus a fifth of x d of x. That's it. Patiently, you have to get this one. Okay, to have to get this one done to get the final answer. So what we do, we distribute it first. Okay. So you can change this one to the x to the half and do the job. So it's going to be a 2 pi. Remember, you have to arrive at the same answer. So it's going to be x times x to the half minus a fifth of x dx is going to be equal to the 2 pi. Okay, 0 to 25. If you distribute it, x times 1/2, that gives x to the 3/2. Okay, minus 1/5 x squared and dx. Okay, now integrate. So that gives it a 2 pi times it by x to the 5/2. 5/2 over the 5/2. Okay, minus, this is a fifth. So that gives you x cubed over 3 and going from 0 to 25. Okay, simplify it. Remember, you must arrive at 1250 pi over 3. And now you check this one first. It's a 5/2. Switch it. Reciprocal. Okay, it's going to be 22 pi times 2/5. Okay, that's going to be 2/5 of the x to the 5/2. And that would be x cubed over 15. Going from 0 to 25. If you put the 0, we get nothing. If you put 25, so that gives it 2 pi times. 2 pi times what? That's a 2/5. 2/5, 25. 25 to the 5/2. 5/2. Minus 25. 25 cubed over 15. Over 15. Okay, that's it. Now 25 to the 1/2 would be 5. Because it would be radical 5. So that will be 5 to the 5th. So this is going to be 2 pi times 2/5 times 5 to the 5th. Okay, minus. And over here, you see this is 25 cubed. It's like 5 squared. Again, you can use your calculator if you like. I don't have it. So I try to find it myself. Okay, so this would be something like 5 to the 6th. Because 25 would be 5 squared, 2 times 3, 6, over 15. Okay, if you simplify one of the 5, so that gives you 3. That gives you 5 to the 5th. Okay, again, you can use your calculator, or I just pull out the 5 to the 5th out, and then I'll be able to simplify it. So that gives me 2 pi, 5 to the 5th out. So the first part give me 2/5. Okay, and the second part give me negative 1/3. Okay, simplify it. So the common denominator over here would be 15. So it's going to be 2 pi, 5 to the 5th. The common denominator would be 15. And on the top, 15 divided by 5, that give you 3. 3 times 2 would be 6. Minus 15 divided by 3, that give you 5. That give you 5. Okay, so 6 minus 1 would be 1. So that will be 1 over 15. Okay, it's going to be 1 over 15 times it by these numbers. And so what I'm going to do, I would like to finish it here. So I write it down here for you. So this would be 1 over 15. So I continue here. So you can see it. So this is going to be kind of a final answer. V is equal to, this is what I have. V is equal to the 2 pi. 2 pi times, okay, that's it. 2 pi times 5 to the 5th. And inside I get 1 over 15. 1 over 15. So one of these 5s and the 15 would be right. That give me 3. That give me 5 to the 4th. 5 to the 4th would be 625. So V equal to the 2 pi. 625 times 3. That gives exactly what we are interested in. Okay, 2 times 25 would be 1250 pi over 3. The same answer. Okay, so it doesn't matter. You see, that's the same answer. 1250 pi third and the 1250 pi third. So either method, the shell method or this method would give you the same answer. Okay, so these are various possibilities. We'd like you to see it so that you understand what is this method all about. Okay, that's it. That's 7.3. And this is where we are going to give you the quiz 1. So the quiz 1 would consist of some problems on the derivative and the integration of the inverse trigonometric function. Okay, then the problem of area between two curves. Okay, the volume of the solid using the test method, the shell method, like the practice quiz that we're going to have. We cover only one more section from this chapter, and it's going to be 7.4, and that's the idea of the arc length, because we need the arc length at the end of the course. We are not going to cover anything else from this chapter. Then quickly we get to our main chapter, which is chapter 8. And that is I think that would be, yeah, chapter 8, method of integration. It take us, a couple of weeks to be able to do it, to change, to finish it. So study this one carefully, because 5 questions on this quiz, and it's going to be repeated again on test 1. After test 1, you are not going to see them anymore. When you are in calculus 3, we have some other methods to do this type of problems. But there are a situation that this method is much, much easier. Okay, that's it. Have a good one. And if you have any question, let me know. Okay, bye-bye.